Okay, this is AP Physics homework on work, page 172, number 20. The situation is we have a 50 kilogram mass. And first of all, it's being pushed at 30 degrees to the horizontal, and then it's being pulled 30 degrees horizontal. And the question asks, where is more work done by the pushing force? So what we really need to do to solve this problem is we're given this distance, so that's not a problem. We're given that it's being pushed at constant velocity. So what we really need is we need this force applied right here and multiply it by this distance. So force applied in the x times the 15 meters will give us the work done by this force of push. The tricky part is looking at force normal. Well, the easy part is we have the weight, but we also have this component right here. Part of the push is literally pushing the mass down into the ground, increasing this contact force here, which is identified as force normal. So this vector plus this vector will equal force normal. Okay, and also, how am I going to get the force applied? Well, I know that this is in equilibrium, so the force applied in the x and the force friction have to be equal and opposite, so that we're going to be in equilibrium. And so once I calculate the force of friction, then that will also be the same value as force applied in the x. Okay, so we can calculate then the amount of work done there and compare it now with this free body diagram. Let's see how our free body diagram now changes when we pull instead of push. And it's all in what happens to the force normal. The weight doesn't change. However, what we have is a reversal in the applied force, or the y component of the applied force. It's now going up. So now I have kind of the opposite situation. The weight is equal to this plus this. All right? So I'm kind of back calculating then my force normal. All right? It would be this vector minus this vector will equal that vector. Okay. So again, we solve the problem then the same way. Once we compute force normal, we can get this force of friction, which is in equilibrium then with force applied horizontally. And I now have a different FP in the x that I can substitute in back here. And then I can get the two values of work and decide which one is the more efficient or effective way to either push the box or pull the box.